we talked about profilers, and I talked about scaling, how it was really nice and fast, and it did memory profiling and all that. Well, friend of the show, Anthony Shaw, said, hey, since you're on this kick for profilers, have you heard about Austin? To me, Austin is either a guy's name or a town in Texas. I hadn't heard about Austin. Have you?
Yeah, I got a neighbor named Austin.
I don't think this is the same thing. So this is like scaling is a frame stack sampler for CPython, meaning it doesn't have like this huge effect of once you run it on your code, it doesn't become 10 times slower as instrumenting versions do. It just asks like, hey, what are you up to really quickly? So that's cool. It's nice and fast. It also is just pure C code. There's no real dependencies like other than like the C runtime, which is in all the operating systems. So it looks at running Python code at intervals, and then it dumps out whatever it finds, which is cool. It has a really simple output, but as you will learn, it has all these interesting ways to visualize that output. So it's sort of its atomic unit of output is a flame graph. So flame graphs are like stacked up sort of things that are colorful, and they also have information. So like the color communicates information and the height. So it's kind of like a graph with like color bars type of thing. And it has the parts of code that are running. If people want to see what that is, just click on the link and it has it right there at the top. And that's cool. So it puts that out, but you can build other tools to analyze that, or you could even make like a little player application that replays the execution of your application in like slow motion, like replays that flame graph over time.
Oh, that's
Isn't that
neat.
Cool? So
yeah,
now is where it gets really fun because there's a couple of user interfaces on top of this like simple output that can be interpreted. So the first one is called the TUI, the Terminal User Interface. Do you see this animated in our little show notes and will be in the...
It's nice. Yeah, it's really cool.
So let me try to describe it. Like imagine you've opened, I don't know, Emacs or something like that. But the top part of it shows the process information, the CPU it's using, the memory it's using, how long it's been running, and then a graph, an active, like interactive flowing graph across the top of like the performance analysis. And then it has something that's a little bit like top, maybe, showing you like what it's currently running, how much time it's using. Is this time being spent on a sub-function call? Like, did I call a thing that called request that is talking to the network, and that's why it's slow because we're waiting on the internet? Or is it actually computationally my stuff running in Python or whatever, right? So what do you think? That's cool, huh?
Yeah, it's kind of like the it reminds me of that bottom part reminds me of the thing that you put the Process Explorer on Windows, where you can look at all your processes.
Yeah, a little bit like Task Manager, but it's actually for like your functions instead of other processes.
Yeah, that's
nice.
Cool.
So that's the TUI, which is going to be a popular one. But you may also want to be on the web. So there's Web Austin, which is another example of making this for the web. So you basically can log into wherever you're running it, connect to it, and it has a D3 flame graph that's like animated of what your web app or whatever process you're watching on that remote system is up to. So it's kind of the same thing, but like more visual, more graphical, like the flame graph is there and whatnot. So that's pretty cool. People can check that one out. You can even pause it and whatnot. And finally, there's this other format called SpeedScope, which can be visualized in other tools. And you can convert Austin output into the SpeedScope JSON format. And there's a sample for that in the repo. If you go look at that, you can load it into the SpeedScope visualizer type of things and have another way to view the data. So this is really nice because so many of these profilers are like, we collected all this information. How would you like it as a, CSV? Or how would you like it as just like random columns in a terminal? And this is so much like, I would not like it that way, please. So this is I really like the visualization because it's one thing to gather the information. It's another to go, oh, I see right there is actually where it's slow. And if it's just a dump of a bunch of numbers, I mean, you can like sort it and whatnot, and you can use cProfile with different sorting options and get it to mean stuff, but it's not the same as like, aha, there's the picture. I see it's red right there and it's really tall. Let's go figure that out.
Yeah, and the web one, the logo's awesome. It's good.
It is really good. Yeah.
It's like a 70s
It reminds me
thing
of
or
Austin
60s.
Powers a little bit. Right?
Yep.
In a non copyright infringing way. Anyway, that's it. If people are looking for a profiler, Austin looks pretty cool. Check it out. It seems like it.
Definitely.
It's definitely one of the contenders. And thanks, Anthony, for sending
All right.
that in. Thank you for watching this segment of the Python Bytes podcast. This video was made during the recording of the full episode. Visit pythonbytes.fm and get the whole story. Subscribe to the podcast and get the entire episode delivered to your phone. Please support our work by taking one of the courses at pythonbytes.fm/courses or learning PyTest with Brian's book at pythonbytes.fm/PyTest. Finally, visit our sponsor shown on the screen here. Visit the link on the screen and get the special offer for Python Bytes and YouTube listeners. Thanks, and have a great rest of your day.